Good afternoon. My name is Todd Papiuadu. I am the field CTO for Nyriad, and I also function as the CTO and overall product owner for Escalate. Thank you all for taking the time to come and have a little view of this demo of Escalate. It's actually a project that we've been working on for the last few months here. We've actually come to deliver Technology Preview 1 today. We want to give you all a demo of that, give you some insight into what we've been building, how that relates to our overall product technology, overall product strategy, and hopefully get everybody excited about the progress we'll be making. So I don't want to bore everybody with too many slides, but we'll actually go through just a few slides here just to give a little bit of context. Also, I do want to say at any time you can actually send me questions using the YouTube interface. I've got my glamorous assistant Mark here who will call them out at the end of the presentation at the question time. So let's kick off then. So this is the Q4 Escalate update. This is actually something that we've been sharing with our partners here. So a little bit of background about Escalate. So Escalate is a strategic project that we've been working with our strategic partners, both Datacom and Rivera. This has been a project that originally was ideated almost 2 years ago now, and we've really come a long way since that original ideation. The first POC was really delivered last year, and this year, right now, we're actually delivering what we call Technology Preview 1. Technology Preview 1 is the initial demonstration of all of the capability that we thought has never been done in the world before. So when we look at the overall project timeline, and we'll take a little look at that in a little second, what we did was we moved up all of the really hard stuff, all of the invention stuff, the stuff that nobody's done before in the world. Stuff at the end of the project is going to be filling in some of the colors, so adding user management, perfecting logging, that kind of stuff is less interesting. What we focused on here was what's not been, what are the really hard things, what are the high risk things, let's make sure we can prove that we can do it, and then we can demo that to our customers and demo that to our partners. Excuse me. And one of the things about this project is we are doing it in partnership with both Datacom and Rivera and their customers as well. So what we're focused on is giving them an article as soon as we can, so we can touch their customers, give them access to for them to see it, so we can get feedback on how it's being used, how they want to use it, how they want to deploy it. That's going to be key for us learning here. So what is Escalate? What is the difference? Escalate at its heart is really a set of disruptive technologies that we're bringing together. We think of them as tomorrow's technologies that ultimately showcase the power of the crown jewels, the core guts of what we do here at Nyriad, which is push things down onto the GPU. Long term, we think that this is going to disrupt the way people think about building and deploying software fabrics and actually building data centers. It has a chance to disrupt the economics and the architectures of data centers for the next 20 years. At the heart of what we do is the GPU. We've bet the company on that. We do believe that we're at the start of the era of the GPU. And just to give you some kind of context around that, today we've been following the CPU wave, the era of the CPU. For the last 30 plus years, where Moore's Law has been delivering improvements in CPU capacity for us, say every 18 months to 2 years. Well, that's topped out now. We see this very clearly in the new chips that are coming out from Intel and the other CPU manufacturers. Moore's Law has come to an end. We can't solve the 7 to 5 nanometer problem because electrons are always going to be the size of electrons. So what does that mean for us? Well, what that means is that a new technology needs to take over, and that technology is going to be the GPU. We believe we're at the heart of and at the start of the era of the GPU, and that's great for us because the GPU is fundamentally a parallel computer, a supercomputer that's been slimmed down onto a chip and stuffed into a server. That's a very different architecture to the architecture of the CPU and the machines that you would build that way. And we're able to take advantage of that because we have a core, deep understanding and core background in GPUs and how to use them as a company, as a software development team. So at the heart of the GPU acceleration, we do GPU accelerated storage. This is our core Escalate product. I'm sure you guys have heard a ton of that in other presentations and other updates from the company. But basically what Escalate does is it takes bits at the bit level and it puts them out onto disk. And it does that in a way where it chops up where it goes so that we have all of that data smeared across all of the disks and make it super simple for us to be able to recover it if any disk dies. It just makes disk safe. So Escalate is the core erasure encoding technology, and we do a bunch of other goodies in line on top of that. Now, one of the benefits that we have by betting on the GPU is that In comparison to a CPU, let's say storing bits and bytes onto the disk took, say, 5 clock ticks. Clock ticks is a thing that chips do, they're almost like a second hand. And let's say it took 5 clock ticks to store and read and write the bits. With the GPU, we see that we do maybe take 2 clock ticks. So what does that mean? It means we can either go and do it twice as fast and just do it in those 2 clock ticks, or we can use the other 3 clock ticks to do something else, and that's what we do. We use those spare clock ticks, those spare cycles, to do things like encryption, compression, real-time blockchain auditing. Those are capabilities nobody in the world can do because of the architecture that we bet on as we built our storage fabric, which is Escalate. So we do the GPU accelerated storage, and we also do the GPU pipelining at a high level in Escalate to do these extra functionalities. That in and of itself is a super interesting product, but we've taken it even further. What we've done is we've brought in the blockchain capability, the blockchain technology, and everybody's heard a lot about blockchain, in the media, and about Bitcoin and cryptocurrencies. That's not what we're talking about. We're talking about the fundamental technology of a distributed audit ledger, a distributed way to basically store state in an immutable fashion. And immutable means you just can't change it. What does that really mean for us? That means that in our fabric, in Escalate, when we store data, we have an immutable, unchangeable audit trail log of everything that happened. So if I get an object, a file, and I store it, from the first moment that we store it, we understand when it was written, when it was read, when it was changed, when it was transformed, when it was moved, when it was deleted, and all of that entire life cycle of that data. So we have the full, as I call it, farm to table of the data. That's incredibly important when it comes to data fabrics and data platforms. Nobody else in the world has this. And I've been building data platforms for the last 20 years now. In my past, I've built a number of databases. I've built a number of unstructured data fabrics. I used to run half of the internet. So I've built a bunch of databases and fabrics in my time. This is actually incredibly exciting, net new technology that nobody else has put together. And the reason we can do it is because we bet on the GPU, because we can do the GPU acceleration and do the blockchain inline as we store data and as we read data. So we take all that, we have this provable audit trail, this provable data provenance of data, and we deliver it. And we deliver it as a cloud. We're betting on Kubernetes, which is a cloud fabric, a cloud distribution system for doing containerized microservices. Now that's a bunch of technical buzzwords that may sound confusing, but ultimately what that means is we can install our platform on more than one server, we can install it into the cloud, and we can basically scale it out, as we call it, horizontally, and scale it up and down on demand as needed. This is exactly the same as clouds like Amazon or Azure or Google Cloud Engine and delivered, and Kubernetes is a technology that enables us to do that, and it's one of the market leading ones. So we're building a core competence here in Cambridge and Nyriad on how to push Kubernetes further than anybody else. I'll be comfortable in saying we're the first people in the world who have built a GPU streaming application running on a GPU inside Kubernetes on top of CUDA, on top of a GPU. We're the first people who have put that all together, and that's part of our secret sauce that we've done in Escalate. So when we think about the overall project timeline, where are we? As I mentioned, we're at Technology Preview 1. Technology Preview 1 is really showcasing all of the hard things, all of the risky stuff, all of the stuff that needed to be invented. And this is part of an ongoing development cycle. We see the usual kind of phase changes that you would see in software development. So we go from Technology Preview to Alpha, which is kind of in the middle of Q1 next year. We go to Beta, which is kind of in the middle of next year, and then full shipping at the end of the year. And within each of those phases, we basically upgrade the kind of capability that we're giving to customers. So Technology Preview, as I mentioned, 1, and then we have Technology Preview 2 coming up pretty soon here, is really focusing on those hard things, and we arrive at Alpha. Alpha is largely architecturally complete. We have the big boulders in place. We know what the things are going to look like, and we've connected them together. And this is something that we can leave at our partners, so we will be installing it at Datacom and also Rivera's data centers, and leaving it for them to have their sales and marketing staff be able to demo to their customers. Between now and then, we're doing demos of this pretty much on a daily basis, as it turns out. I think we're averaging a couple of demos a day at this point, because there's such a pent-up demand and interest in this product. So Alpha, gets us, architecturally complete. Beta gets us to be functionally complete with some rough edges. It's something that is mostly there. We can use it just like any other beta product out there now in the software world. People can use it. We can start to drive revenue. We can enable our partners to drive revenue on it. And then the pilot is at the end of the year, and that's really when we finish it up and say, hey, we've got the first version done, and then we look ahead again. Now, what I want to really emphasize on this is this roadmap is actually has been committed to our partners based on current resourcing in the Escalate team. And one of the things we're looking at is bringing in the end of the project cycle by adding more resources to the team. It didn't make sense to do it beforehand because it doesn't matter how many people we throw at the invention, it's not going to make it go faster. This is one of those things we talk about in software, which is the mythical man month. You can't throw, 9 people at making a baby and get a baby done in 1 month. It's just not going to work, right? So it's always going to take 9 months, and the invention is going to take what it's going to take. But we can bring people in at the end of the process so that we can, as I say, paint in the numbers, add user management, add some logging, clean up some of the styling, that kind of stuff. That's where we can accelerate. And this is actually something that our partners are asking us for, and we're seeing good demand in the market, so we want to do that. So we've already begun that. We're adding people to the Escalate team as we speak. So this is a kind of view of the project. If you have questions, as I mentioned, send them to Mark. He'll read them out to me at the end of the session. What I want to do is really focus now on demoing the product. The proof is in the pudding, as I like to say. And we're going to look at a real-world use case. So a real-world use case is based on requirements that we've got from our partners. Both of our partners actually are looking at this, and it's real-time streaming video ingestion and doing real-time machine learning and algorithmics on that data as it's streaming in. So the demo is, we're going to walk you through a demo, and the demo is actually simple but powerful at the same time. Simple in that you'll have seen some of the assets that we use. What we're going to do is we're going to take a video that we took outside of our office here in Cambridge. It's actually all the cars going by. And we're going to upload that video, we're going to put it into our platform and show us running in real time a machine learning neural net that's going to be outputting some results off that video. That's actually super compelling as an application, and nobody else in the world can do the streaming real-time stuff on top of the GPU. Generally related to other clouds, you have to upload the data first, and then you have to process it, post-process it. So as we walk through the demo here, and I have one of the senior architects on the team, Serge, just off camera here, who's going to actually be driving the demo for me. We have a pretty good double act at this point going on a daily basis here. So this is a very basic view into Escalate. This is Escalate exports technically 3 APIs. We have an S3 API, which is a clone of Amazon AWS's object store. An object store is where we can store data, we can store objects, we can put content. And we've cloned that because we see a lot of usage of that in the market. We have what's called a Lambda API, and a simple way to think about that is Lambdas are small little plugins of code that you can upload and then run that on some of the data you put into the bucket. So it's just like a plugin architecture. There's a lot more complexity underneath it, but that's a simple way to think about it. And then we have our Order API, which is our blockchain API. And we're going to look at each of these in the context of the overarching demo. So the first thing we're going to do is we're going to go to S3 and we're going to create a bucket. And you can think of a bucket as just a place. It's a place that we're going to put some data, and for the purposes of the demo, we're going to create a demo bucket and create that. Now we have somewhere we can put some data. Well, just being able to upload data to a website isn't that interesting, really, is it? We've seen that for years now, right? So let's do something a bit more interesting. What we're going to do is we're going to create a Lambda. That Lambda, as I said, is a bit of plug-in of code, and this is some code that we've created before. And the code is actually the code that runs the neural net, the machine learning neural net, in real time on top of the data when we upload it. So we're going to give that a name, and then we're going to upload it. And what you can see here is this is actually a list of all of the different runtimes, different code runtimes, and languages that you can use to program on top of Escalate. What we've done is bring in the CUDA runtime. And a CUDA runtime is a very specific programming environment runtime specifically for GPUs. This is actually created by NVIDIA, who are absolutely the dominant market leader when it comes to GPUs. We are the first people in the world to pull that in and put it into a Lambda serverless environment. Now, you can't do this in AWS, you can't do it in Azure, you can't do it in Google Cloud Engine, you can't do it anywhere. This is some of the invention stuff that we did. So we've enabled the CUDA runtime, and we're going to upload a little zip file that includes some code that we've already written. As I mentioned, this code is the neural net that's actually going to do something interesting on the video that we uploaded. So we upload that zip file, and then we're going to attach it to the bucket. And what does that mean? That means that, say there's a bucket there, we're going to attach the little plugin. When I put data into that bucket, the plugin is going to do something in real time as the data is streaming in. And so what we're going to do is we're going to create it and attach it to an event type called streaming put. Now, as you saw in that little drop down, there's a bunch of event types. Again, we've cloned the Amazon Lambda interface, but we've extended it with 2 new interfaces. There's a streaming put and streaming get. Simple way to think about that is a streaming put is I'm pushing data into Escalate, or again is I'm pulling it out. And in real time, whilst I'm pushing it in or pulling it out, I can run these plugins of code on the data. We're going to show you a demo of doing that, but another way to think about it is, imagine if we had 1,000 video cameras that were streaming data into Escalate, and we were running machine learning algorithms on them in real time. This is actually something we could do. For the purpose of the demo, we're just going to upload a file from a laptop and show you this happening. Again, you can't do this capability anywhere else. You can't do it in AWS, you can't do it in Amazon, Google Cloud Engine, you can't do it in Azure. This is an extension that we made specifically to run on the GPUs. So when we go and run this code, we're going to upload our video now, which is going to be a little video that we took, as I said, of cars going by the office here in Cambridge. And as we upload it, we're going to start to send data from the laptop here locally that we're running this demo on up to the cloud. And as we upload it to the cloud, we're going to see that the results are happening immediately as we stream the data in. And so down here, as I'm blocking here, you can see that we're actually uploading the video as it goes. And out of that, we've actually created a new set of objects. So in real time, as we were streaming this video up, a set of other objects got created in a new bucket. And when we go closely and look at these objects, what we'll see is they're actually frames of cars. So we can preview some of these. And we see a frame of this car. Now what happened here in real time was that we ran a neural net algorithm. It looked at the video and it said, I'm going to identify something that looks like a car in the video. When I identify the car in the video, then what I'm going to do is I'm going to identify the license plate. So we did all that in real time, and we saved this object off into our S3 buckets, right? So we can see that these frames now have a license plate at the top. This is the name of the object we've identified. This is actually, I think, a pretty cool use of the streaming application and the streaming CUDA runtime. So we've now shown you uploading data and doing streaming data and streaming analytics and streaming machine learning on that. This is all part of using Escalate as a data fabric. Now, a data fabric is just a way to store data, and so we can do other operations on that data. We may want to add more data, we may want to delete stuff. That's interesting, but everybody's used file system, or everybody used kind of like cloud storage, like Dropbox or Box or whatever it is, or your iCloud storage to store data. What's interesting about what we do? Well, we've added the blockchain as a technology that basically gives us this immutable audit trail and audit ledger of storing data in the platform. So every single thing that happens in the platform, we record. And because we record it, what we do is we cryptographically sign it and store that hash into our blockchain, which means we have an immutable proof of everything that happened in the platform. And that's the entire life cycle. So if we go in and look at the blockchain, we can see, in this case, a whole bunch of data of things that were going on. And gets are when we were like pulling the data out, and puts are when they were being put down there. And then we have the hash that goes with it, and we have the date, and we have the name of it, and other things that are interesting about those objects. Why does that matter? Well, because what it means is that we can at any point go back back in time to a particular point of the system. So we built a time machine in the sense that if any of you have Macs out there, time machine on your Mac allows you to basically go back in time to an early point on your Mac in case you deleted a file or you want to see an older version of it. We can do exactly the same. So if we look in here, we're going to pick a particular number plate that we like for the purposes of this demo. It's going to be this one here, LLR682. This is actually, the car LLR682 belongs to one of the guys that works here at Nyriad, essentially Tyler. He heads up our tools team, and he didn't know he was getting caught in the video as he was driving by the outside of the office. So what we can do in here is go here, here's this car. It's a pretty nice car, actually, for a 19-year-old or whatever he is. This is one of the benefits of having no mortgage and no kids. You get to spend all your money on a sweet ride for a huge stereo in the back of it. I'm jealous, as you can tell. Right? But we could go in here and say, okay, we're going to just delete this like normal, right? I'm just, this is just like using any system. I could, delete it. And now, when we look in this bucket here, this object doesn't exist anymore. We've deleted it. Now, maybe that's, oops, I didn't mean to do that. I was a database administrator. I was using Data Fabric. Most of the time in Cloud Fabrics, that data is now gone. Imagine, as one file is kind of like simple, but imagine I just deleted 100 terabytes of video and evidence. That would be a big problem. Now, we can actually go into our blockchain and say, where did that happen? What was the life cycle for that particular number plate object? I want to go back and I want to bring it back out from, back in time. So if we search and filter specifically for this number plate, we can see the full life cycle of here. So it was originally put when it was put out of the machine learning algorithm, and then we did a get when we viewed it, and ultimately we did a delete. So we can go back to that original version of it. and bring that back out, out of cold storage, as it were, because we have a full cryptographic hash, a full blockchain of the entire data provenance of this object. And one of the interesting things is that because we store the full life cycle of the objects, we also sign and store the version of the code. So the version of the code that we ran, the machine learning algorithm, is also signed and hashed and stored. So at any point, say in 2 years' time, let's say there was an evidentiary hearing in court and we need to go back and algorithmically prove what our algorithm did, we have a version of it, so we can go back in time. So this is one of the huge benefits of Escalate as compared to any other data platform. We can go back any point in time and reprove and replay everything that happened at that particular point. So here we put that back, and that's pretty interesting, right? That's actually new capability. But let's take it even further. What happens if it wasn't somebody who was just doing it on purpose? Let's imagine that actually somebody hacked into the system now. This is a hacker, this is an intruder. My parents, I live in California, maybe this is one of the Russians, right? Who's going to hack into the system. And what we're going to do is we're going to run a little script to simulate somebody hacking in and completely eliminating all evidence of that number plate from the system. And this is what we did here, a bunch of black and white text, but ultimately you can see Escalate has been hacked. So you can now imagine that that number plate doesn't exist in the system, doesn't exist in the file system or in the bucket. It also doesn't exist in the blockchain. It's gone, it never existed. So we can't restore it, we can't undelete it in this case. As you can see, it doesn't exist at all. Now, for most data fabrics, that would be a problem. You'd be like, oh, I can't get back to that data at all. Do I even have the source data? Can I replay it? That's not so much a problem for us. What we can do is we have a capability that will be on top of the blockchain to highlight that. So, for most enterprises, they are generally hacked about 9 months before they find out. On average, and most of the global 5,000s, when they're hacked, it's 9 months before they find out. And so the hackers and the intruders have been there wreaking havoc in the background, and you just didn't know about it. And I know this personally. I was actually the CTO of Splunk. It's a public company. We used to do about $500 million worth of revenue in security data and securing our customers. So in this case, we have a new capability in Escalate. What we can do is we can export the blockchain that proved, cryptographically signed and proved everything that happened in the fabric, and use that to verify what was going on in the platform. Now, why does that matter? Well, if you can have an external third party be your trust verified, to be your source of trust, you can prove. So if I'm a customer of Escalate, I can say, Escalate, I want to know, every month you need to prove to me that you have all of my data, you haven't lost it. And we can do that by exporting the blockchain. Remember, it's immutable, we couldn't change it. Or I can be a third-party trust organization that mediates trust within a whole bunch of government organizations. Or, something very prevalent and used at the minute, I can be a third-party trust organization that's managing a supply chain, asserting and proving cryptographically that everything that moves through the supply chain was actually real. And so for Supermicro, they might actually want to have this feature right now in their supply chain data management system. So what we can do is we can export that snapshot, and we download this little file, and then we're going to go to another application that we have. And so this application here is our little verification app. Now this is a way, again, to demo what it might be to be like a third-party trust organization, like VeriSign used to do for certificates. So we trust people to, sign and manage all of the, like ICANN to do all of the domain names around the world, right? Or credit card agencies, right? So this is a third-party trust application, and we're going to upload that snapshot that we took. And what this application has been doing in the background is periodically getting an update from the Escalate data fabric on the state and the blockchain that it believes, the fabric believes it had. Now, you could set this to do every minute, it could be every hour, it could be once a month, it could be every time that you execute some smart contract that matters to your business. It's up to you from a business standpoint when you do it, but you can actually use this to verifiably prove the data of the platform. So what we've done is we've now uploaded that blockchain snapshot, and we can see a very text-heavy way of looking at this. And in this block here, we can see there's 2 transactions, 1, 2, and all of the blocks are going to look something similar like that. Now, what if I want to verify that snapshot that I took after the hacker hacked into the system with the last known good version that the verification action took? So we do that, we run that, and we get a mismatch. Red is always bad in the UI, so the red is telling us that there's a mismatch here, and that means that the version of the snapshot that I took after the hack doesn't match the one before. So we know there's a problem now. As a trust organization, you can call your customer and say you have a problem with the data. As a customer, I can say, hey, what happened to my data? If it's a supply chain, maybe we can go and look at what happened. Where did this happen? How you remediate this as a customer is really up to you. It's a business decision. It may be that you go, oh, I just want to go back to my last known good backup, right, which is offsite. It may be that you go, I got to call the FBI, somebody's hacked into my system. It may be that I've got to call my financial auditor because there's a problem with all my audit trail in my supply chain and I've got to restate my earnings. These could have huge implications, especially when you think about it in the context of GDPR, which is a data regulation that is been coming out of Europe and is now sweeping around the world. And this is one of the big mega trends that we're betting on as a company, and that Escalate talks directly to, which is verifiably proving what happened to people's data, to their personal information data, to their financial data, being able to exchange that as a contract between entities and prove verifiably that this is actually accurate state of what happened to the data. So we see here that there's red is bad. We can see on this side there's 2 transactions, and on this side there's 3. We can also see that this one here is the one that got removed. So this is the one that got deleted by the hacker, right? So at this point we've proven that a hacker has actually done something to the system. So this is a real world use case of us taking in video information, running real time machine learning algorithms and AI on top of the video stream and doing something with that output. Again, this is something that can be applied in a whole range of contexts, and we're already seeing a bunch of these contexts around the world. If we slip to the next slide, what we'll talk about is some of those use cases that we see. So potential pilot applications. We are now engaged, very meaningfully with both Datacom and Nyriad and a whole bunch of other partners, actually, and potential customers, looking at a suite of applications that have immediate applicability to Escalate. These largely fall in initially 3 large buckets. There's the computer vision stuff. So you can see that you can see the demo we gave today. You can imagine that will be useful for traffic cameras. That could be useful for buildings. That could be useful for airports. That could be useful in correction facilities, ports and trains, right? Anywhere that the streaming video, which is absolutely a mega trend that's happening around the world. Smart cities are installing cameras all over, and being able to actually look for license plates or track targets, look for faces in the crowd, look for particular vehicles, look for containers and a container, shipping factory. These are all things that we can do now in real time on top of Escalate. There's also document processing. So document processing comes in many forms, but it could be taking a bunch of initial PDFs or Word documents that large-scale government organizations just have tons on, that are all stuffed down onto some storage somewhere, and you want to process them and run some kind of lambda function again to do machine learning, maybe to do analytics, categorization, filtering, sorting, and then or even prove. So this is a real world use example. We have one of our partners suggesting that the corrections department here in New Zealand want to be able to take paperwork that they have, which is currently real paper now that exists all around the prisons, is manually filled in, and then that paperwork gets sent around the little binders and folders by hand, and they have no idea who's read it, who's seen it, who's touched it, who's signed it. They want to be able to automate the scanning of that, turn it into an electronic document, and then have a verifiable proof of who read it, where it went to, who approved it, who signed off on it, and be able to use that in evidentiary proceedings, right, as you go forward, right? And you can see the value of the blockchain on top of our data fabric for that. We also see a tremendous amount of uplift in just classic data mining applications, and you can imagine there's a ton of people today using GPUs to do all sorts of analytics and machine learning, TensorFlow applications, model training to do targeting, analytics, personalization, product delivery. There's a whole bunch of stuff that you can do running that stuff in real time on top of data. So this is an initial sample actually that we've been working with our partners. What I would say is every customer that we go and meet with has a whole new really interesting set of things that are like, oh, so I can store that data and process it in real time, run my GPU code, and have a verifiable audit ledger of it. What about if it's drone feeds? What about if it was like the number of trees in the forest? What about if it was colors? And we have a whole bunch of things that pop up. Every single person that we're talking to who immediately sees the value of being able to do this in real time and have this verifiable proof on the data fabric that they can never do before. Do we have any questions?
Nothing so far.
Okay then. Anybody out there, start typing. How about a question from the crowd?
Looks good.
Well, if you do have any questions as a follow-up to this particular video stream, definitely feel free to send them in. You can get to me directly. I'm just Todd at Nyriad.com. You can get to us through our regular kind of like investor
We have one
relationships. Sweet. You have a
So,
question coming in. Thank
David
you.
C. Martin says, "Who's blockchain?"
Oh, hey, David. Who's blockchain? Great question. So we use our internal blockchain, so it's actually a distributed ledger that sits inside Escalate, but the external API would allow us to put it anywhere. So we could put it into Hyperledger, we could put it into somebody's private blockchain, we could put it into a public blockchain, just, you know, the Bitcoin blockchain, so it would be immutable out there. That's part of what we focused on. It really depends where that third-party trust is. We actually, I think, have some really interesting opportunities to go and take Escalate and put it underneath Watson, I think, as you know, and put some of this, put the immutable audit ledger into Hyperledger, and, you know, export the data there. That's actually a great question, and part of the reason why we've exposed this API. Within our platform, we know it's verifiably provable, and we want to be able to export that out to third parties so that we can also continue to prove that, right? And I think there's a whole ecosystem of people that we can connect to augment the product capabilities right now.
Got two other comments which are good job, Todd. Great job, Todd, and good presentation.
All right, thank you. I don't know who they came for, but I appreciate it.
And exciting, well done.
Awesome, very good. Well, I appreciate it. I don't know if you guys can hear in the background, that's Mark reading out your appreciative comments. So, unless there are any other questions, I think we really appreciate you taking the time to come and watch what we're up to. We're very excited about it. As I mentioned, you can get hold of me directly. You can get into our usual kind of like investor relations, which you already have contacts through, or get hold of Douglas. We will continue to keep you updated, as we go, basically. I think this is a very exciting product. As I said myself, I've been around the block a little bit. I worked in Silicon Valley. I've built a bunch of kind of like data fabrics over time, been, pretty happily successful doing those. The reason I'm over here in New Zealand, I'm here for a month this time. I've been over in July and also August. I think this is the most exciting thing that I've seen in the last 10 years, and it's something that I personally want to be a part of and be able to build and deliver to the world. And in the end, we'll all look back and go, yeah, we were part of Nyriad. Just like people look back and go, yeah, I built Google or I built Facebook. Those are some of my friends, so I want to be able to tell them I built Nyriad.
Okay, we have another question.
Oh, another question. Awesome.
Key manager, question mark.
Key manager, question mark. Might need a little bit more context on that, honestly.
I'm guessing, how does the key manager work, or what key
PKI?
manager? Yep.
How are we managing our keys?
How are we
That's from
managing?
David Martin.
Maybe we'll have to take that one offline. I just need to understand a little bit more around what the essence of the question is. But we can definitely chat offline, David. You have my number.
Cool.
Very good. Okay, awesome. Well, thank you very much, everybody. Appreciate you taking the time. Definitely get hold of me if you need anything else. And David, I'll follow up with you straight after the presentation. We can understand more what you're asking about. Thank you very much.